Good morning, everybody. My name is Mojolaoluwa, and last year I worked with Dr. John Molina at Bronx Community College. He just showed us basic stuff about forensic science. Forensic science is any application of science in law and legal department. It ranges from basic applications like medicine, toxicology, to even in applications within the court, like expert witnesses. It was developed in the 18th century when people just started investigating crimes by comparing evidences and gathering like a large database of methods and other evidences. I'll just be basically reviewing one of the methods. It's called mass spectrometry. It's also been applied in other fields like physics and chemistry. Mass spectrometry basically works by getting a sample from a crime scene, and there's an inlet at the very end of the instrument. It works by converting the sample into a gaseous form because it applies a certain pressure, high pressure, and heat. So after the sample is converted, it's moved into the mass analyzer, and the mass analyzer works by exposing the particles to a charged material. The charged material contains electrons, and the electrons make those materials get positively charged, and they move to a magnetic field over here. And the magnetic field basically separates the particles into their different shapes and sizes, and then there's a deflection, and the deflection is caught with a software program on the computer. So this program really measures like the mass to charge ratio of each sample of particles that is used. As I said, this is the first part, is the ion source. It works by converting by heating to electrons and giving the particles a charge, and then they move to a volatile filament. And there are some special cases where we use volatile samples, so they must be preserved first using a vacuum before they are introduced into the mass analyzer. This is just information about the mass analyzer. It works on the principle that the radius of deflection is inversely proportional to the mass of each ion. So the lighter ions are the ones that get detected first, and the heavier ones later on. And the detector is basically a computer program that compares the mass to charge ratio of each particle, and it's displayed at the end. And this is another another improvement on the mass spectrometry method, because it's a method that's used frequently. So this method actually, instead of the vacuum, it connects it with a gas chromatography, which is the first part. So we introduce the samples to the first part of the gas chromatography, so you get it in the purest form before it's introduced to the mass spectrometer and the other processes go on. This is the usual way they apply it in forensics. They get evidence from a particular center, like a coroner's office, the crime scene, and they make sure it might be trace evidence, really little ones, and then they preserve it using asphalt and other packaging methods, and then they send it to people who do these programs. And the conclusion is that mass spectrometry is a very useful method in various investigations and other various fields of science, including physics and chemistry. And I'll just put a glossary and some references. I would like to acknowledge Dr. John Molina and Professor Thomas Brennan from Bronx Community College. And also I want to acknowledge Kim Dan, who worked with all the students, Dr. Sat, and all HCS staff members and students.
What was the computer program called? I think it was in the second slide of the math spectrometer.
Oh, I said it's a detector. I don't know what program it is.
What about the pills? Like, what kind of pills are there? Do you guys have evidence?
No, that's just a general example. It could be anything from trace evidence. They just use small samples of them, and then they are converted into particles.